Assalamu alaikum warahmatullah. Dear students, today we are going to do question number 4, exercise 7.1. The question number 4 is show that the diagonals of a square are equal and bisect each other at right angles. Show that the diagonals of a square, you have to prove that the diagonals of a square, they are equal and bisect each other at right angle. So we have given, let this ABCD is a square. ABCD is a square and AC and BD are its diagonals. AC and BD are diagonals intersecting each other at point O, intersecting each other at point O. So this is given and we have to prove that these two diagonals are equal. We have to prove AC is equal to BD and we have to prove that these bisect each other. These bisect each other means OA should be equal to OC and OB should be equal to OD. OB is equal to OD. And we have to prove that these bisect each other at right angle. So we have to prove this angle should be 90 degree or this angle is 90 degree. So let us say this angle AOD, angle AOD. We have to prove that this angle is also, this is 90 degree. We have to prove this. For proof, let us take two triangles, and triangle ABD. ABD in triangle ABD and triangle ACD. This triangle ACD. So in these two triangles, we find that AB is equal to DC. AB is equal to DC because these are the sides of a square. We write sides of a square. Second thing is, in these two triangles, this AD is the common side. AD is equal to AD. AD is the side of triangle ABD and AD is also the side of triangle ADC. So it is the common side. And third thing is, the angle DAB is equal to angle ADC. ADC, each 90 degree because these are the angles of a square. So this angle DAB is equal to angle ADC in these two triangles. Therefore we find this side and this side and this angle. So we find in these triangles, one is this side, second thing is this angle, and third thing is this side. So side angle side angle side congruency. So as per SAS congruency, these two triangles are congruent. So therefore triangle ABD is congruent to the triangle ACD. SAS congruency. When these two triangles are congruent, then their sides are all corresponding sides are equal. The corresponding sides you see in this triangle ABD, the hypotenuse is BD. The hypotenuse is BD. Therefore, BD is equal to, and in this triangle ADC, the hypotenuse is AC. So AD should be equal to AC, as you had to prove these two diagonals should be equal. BD should be equal to AC. BD should be equal to AC. You had to prove this. So we proved CP, CT. These are the corresponding or congruent parts of the congruent triangles. So BD is equal to AC. So the diagonals hence proved. Hence first thing is proved. Now second thing is, now let us take the triangles OAB, this triangle. Now in triangles OAB and triangle OCD. So in these two triangles, this angle 1 is equal to angle 2 because this line is parallel to this line and this BD is a transversal. So these two angles are alternate angles, so they are equal. Similarly, the angle 3 is equal to angle 4. They are also alternate angles. So angle 1 is equal to angle 2 and angle 3 is equal to angle 4 because they are alternate angles. One thing more, AB is equal to DC. AB is equal to DC because they are the sides of a rectangle. The sides of a sides of a square. They are the sides of a square, so they are also equal. So we find that in these two triangles, three things are equal. Three things are equal. One thing is the angle, second thing is also angle, and third thing is side. Therefore, these two triangles OAB, therefore triangle OAB is congruent to the triangle OCD, OAB and OCD, Therefore, triangle OAB is congruent to the triangle OC and D. You see here angle, and this is side and this is angle. So angle, side, angle, congruency. Angle, side, angle, congruency. So when these two triangles are congruent, their corresponding sides are equal. So the corresponding sides of these two triangles are, so OB is the side of this triangle and OD is the side of upper triangle. So OB should be equal to OD. OB is equal to OD and OA is equal to OC. OA is equal to OC. So we had to prove here OA is equal to OC and OB is equal to OD. These we also proved this. So this shows that the two diagonals intersect each other. They now bisect. We had to prove that the two diagonals, they should bisect each other at point O. So we proved that these two diagonals bisect each other at point O. That is why OA is equal to OC and OBO is equal to OD. So we proved this thing also, hence proved. The last thing we have to prove is that this angle should be 90 degree. We had to prove that two diagonals bisect each other at right angle. So this angle should be 90 degree. So angle AOD we have to prove is 90 degree. For this, to prove this point, we have to take these two triangles, triangle AOB and triangle, these two adjacent triangles, AOB and AOD. Now in triangles AOB and AOD, in these two triangles, this AO is in these two triangles, the AO is the common side in both triangles. AO is equal to AO because this is the common side. Second thing is AB is equal to AD. AB is equal to AD because these are the sides of a square, of the same square, sides of a square. Let us write, these are also opposite sides, but it is the same thing. We write sides of a square. And the last point which we need is that OB is equal to OD, which we proved here. OB is equal to OD. So OB is equal to OD is proved here. OB is equal to OD proved above. It is already proved here. So side, three things: side, congruency. The two triangles, therefore triangle AOB is congruent to the triangle AOD. So these two triangles are congruent. When these two triangles are congruent, their all angles at their all corresponding angles, they should be equal. So the corresponding angle, let us see in this triangle here at the center at point O is AOB, and in this triangle AOD, these are the two corresponding angles of these two congruent triangles. So AOB should be equal to, now therefore angle AOB is equal to AOD. AOB, AOD, because CPCT, CPCT, oh, here it is also CPCT, CPCT. These are the corresponding or congruent parts of the congruent triangles. So also here CPCT. But these two angles, angle AOB plus angle AOD, these two angles are also 180 degree because it is a linear pair. Angle AOB, this angle and this angle, these two angles, they are linear pair, so their sum is 180 degree. So from these 2 points, from first and from this second point, from first and second, we get that each angle AOB and AOD, they should be 90 degree each, so that 90 plus 90 makes 180 degree. So we get here that angle AOB is equal to AOD and each is 90 degree. So this was the last point which we had to prove here, that at least one angle at the center should be 90 degree, but we proved that two angles, this angle and this angle, the two angles at the center, each is 90 degree. So the AC and BD, they bisect each other at right angle. So this point is also proved. So we write hence proved. Thank you.